This is HRW99P017. We've got a boat on a flatbed. The dog walks along the flatboat here until it stops, and while it's walking, the boat moves a little bit, and we want to know how far the dog is in shore from when we're done, or when we start. Okay, so the trick here is, as the dog walks along the boat, that's a force internal to the boat-dog system, and so the center of mass of the boat-dog system should not move anywhere. So let's look at where the center of mass is before the dog moves. So I'm going to say the shore is at 0. Okay, that's the shore. I've got two particles. I've got the center of mass of the boat. I'm going to call that boat B, and it's B1 because this is before the dog moves. This is the initial conditions here. Okay, and then the dog. I've got the dog is a little further out. That's the dog, and it's before it moves. Okay, D2. I'm not using X's because I need the before and after, and it's just too many subscripts, so I'm just doing this. Now I know this one, okay? I know that one, it's 6.1 meters. Okay, so this is a known. Yay, that's good. But we don't know this. However, we do know their masses. Okay, we know that the mass of the dog, come on, is, where is it, 4.5 kilograms. And the mass of the boat is 15 kilograms. 15 kilograms. Then the dog is going to walk. Okay, now the shore stays in the same place, so that's 0. I don't know where the center of mass is. I can guesstimate, or I can estimate. The center of mass should be somewhere between the center of mass of the boat and the center of mass of the dog. The boat has more mass than the dog, so it should be closer to the boat than the dog. So I'm going to just guesstimate and say the center of mass is right here. Okay? In which case, after the dog moves, the center of mass still has to be there. The center of mass cannot go anywhere. Okay? But the dog moves closer to shore. Whoops. Oh, come on. Wookie, wookie. Okay? So I don't know how much closer to shore, but I do know it's closer to shore. I'm going to say the dog moves, let's see, it says it walks 2 meters. It's definitely still on the boat. I'm going to say the dog walks to here. So I'm going to call that the position of the dog number 2 because it's after it's moved. And when he was walking, the boat would have moved too. Okay, in fact, the boat, I'm going to say the boat moved to here. I know that the center of mass is still closer to the center of mass of the boat than the dog, so that's why it's kind of over here to the left a little bit. I also know that, so B, the center of mass of the boat moved. Okay, it moved like, a little bit. Okay, so that distance that it moved a little bit to the right, and it moved by B2 minus B1. So that distance is B2 minus B1. The dog also moved. It moved from about here to here. So that would be, what is that? That's D1 to D2. So it's well, yeah. The change is D2 minus D1. Actually, I shouldn't have made this a double-sided arrow. It moved to the right. So there we go. Okay. All right. Now it does say the dog walked 2 meters along the boat. Okay, toward the shore and then stops. Okay. I'm going to go a little full screen to 2 meters. Whoops. This is from the last problem or some other problem. There we go. Okay. Didn't see that until I made it full screen. Okay, so I know that the dog walked 2 meters, but here's the thing. When it walked 2 meters, some of that 2 meters was used to actually move the dog, but some of that 2 meters was used up to move the boat. So like this distance and this distance should add up to 2 meters. Alright? So if I got them going in the same direction, like call this displacement of the boat, and call this, so this is displacement of the boat, and call this displacement of the dog, okay, then 2 meters should be the displacement of the boat plus the magnitude of the displacement of the dog, not boat. Now I had to do magnitude because technically speaking, the displacement of the dog is a negative number. But I want to add up like these distances, not technically their displacements. Like I want them both to be positive. So when I do that, basically to make this into a positive number, I'm going to switch the directions. So it's like d1 minus d2 instead of d2 minus d1. So what I really have here is that 2 meters, I'll go with a thicker pen, it's hard to read. 2 meters, and you know what? Yeah, 2 meters. That should equal, well, the displacement of the boat is b2 minus b1, and then plus the displacement of the dog, d1 minus d2. Or rather, the distance the dog moved, not really the displacement anymore, because displacement isn't a vector. Anyway, stop mumbling. Okay. So I'm just going to leave this here for a second. And let's go look at this center of mass thing. We're going to set this up so we have the equation for center of mass for both of them, and then I know they're equal because the center of mass is in the same place. So for the first picture, sorry, I have hiccups now. For the first picture, the center of mass would be center of mass. It would be the mass of the dog times the position of the dog plus the mass of the boat times the position of the boat divided by the mass of the dog plus the mass of the boat. Okie dokie. Then that should also equal, after the move, it should equal the mass of the dog times the position of the dog plus the mass of the boat times the position of the boat divided by the total mass of the dog plus mass of the boat. Okay. And again, this should both be equal because the position of the center of mass really should not change. Okay, so right away, I've got this on the bottom of both sides, so it can just go away. Go away. So now what I have is mass of the dog times the initial position of the dog's center of mass plus the mass of the boat times the initial position of the center of the boat equals the mass of the dog, come on, plus, or times the position of the center of mass of the dog plus the mass of the boat. Okay. I'm going to combine some like terms for the masses. So for instance, if I pull this to this side, and I pull this to this side, okay, what I get is, well, on this side I've got an MD. I'm going to go ahead and pull that out. And then what I have is I've got a D1 minus a D2. Okay. Then on this side, I've got, let's see, MB is the common thing. Okay. On this side, I've got a positive B2 and then a minus B1. Okie dokie. Well, this, see, this looks an awful lot like this. And this looks an awful lot like this. So I'm going to rearrange this equation to get one of those and plug it in here. Now the thing that they asked was, what is the final position of the dog? So what I want the D's. The D's need to stay. So what I'm going to solve for is the B stuff and then plug it in. So solve this for this chunk right here. And I do that by adding this quantity to both sides. So I know that, for instance, if I add this to both sides, oops, minus D2, add that to both sides, then what I get is that the quantity B2 minus B1, come on, equals 2, oh, I don't want to add it, I want to subtract it. Why did I do that? I don't know. This should be subtract both sides. Okay. Subtract, come on, subtract the quantity. Subtract the quantity. Ooh, wakey wakey. Okay. 2 minus the quantity D1 minus D2. Okay, so I'm going to take this chunk and I'm going to replace it over here. So now I've got mass of the dog times the quantity D1 minus D2 equals mass of the boat times the quantity, and actually I'm going to get a couple things, so this should be brackets. B2 minus B1 equals the same thing as 2 minus D1 minus D2, like that. Okay. All right. I'm going to distribute this MB. So this side stays the same for now. Okay, I distribute the MB. Come on. Come on. There we go. All right. Now, I'm going to treat... well, actually, I could distribute here and then put some like terms together. What I did in class today is I'm going to move this term, this whole term, over there. Okay, so now I have mass of the dog times the quantity D1 minus D2 plus MB, because this was minus, right? So to get it over here, I do plus D. That's a D. That was weird. Did you see it shift like that? That was crazy. Okay. Equals 2 MB. Okay. Now if you look, what I have is two different things multiplied by this quantity. So I'm going to treat this quantity as a variable. So I'm going to combine these like terms, and what I get is the mass of the dog plus the mass of the boat times the quantity D1 minus D2 equals 2 MB. I'm going to divide both sides by this quantity. I'm running out of room. No. No. No, stop. It's getting really sloppy. Okay, in fact, you know what? You've been following along this whole way. I'm going to go over here and erase some crap. Let's see. So I don't have to flip the page. Let's erase this stuff. Let me see. You can go back in the video and like check out what was written there if you really need to know, right? Right. That's a nice thing about YouTube. Okay. Well, there's lots of nice things about YouTube, but that's one thing. Okay. So now I've got D1 minus D2 equals 2 MB over MB plus MD. And then I want D2, so I get D2 alone, and I end up with D2 equals, let's see, that would be D1 minus 2MB, come on, over MB plus M dog. Okay. If I put all the numbers in, let's see, D1 was 6.1 minus 2, the dog, wait, that's the boat. The boat over the boat plus the dog. Let's see, what is that? That's 19.5, I think. Let's see, you got 15 plus 4 is 19, and then you got the 0.5. Yep. Okay, so that gives that the dog's second position is 4.56. Okay. Oh, that doesn't... I got really sloppy, sorry. This is like 6.1 minus this whole quantity over here. Getting sloppy. Alright, so meters. Let's go check that. 4.56? Yep, we got it. Sorry about the sloppy math. Yeah. Yuck. Probably would have been better to, at this point, to just distribute everything and combine like terms and solve for D2. Probably would have been better. Try that. See if it's any better.